While 19th century London was a place where dreams often met dead ends, one boy's curiosity would light up the world. Michael Faraday came from the slums and revolutionized physics. Born in 1791, Faraday grew up in a poor neighborhood south of the River Thames. He barely had a primary school education. What he lacked in money and education, he made up for with an insatiable curiosity. He started working as a bookbinder at the age of 13. Growing up, he heard about the discovery in Italy by Alessandro Volta of the voltaic cell, or battery, which, for the first time ever, provided a continuous flow of electricity. Before that, devices like tinfoil-lined glass jars stored electricity but released their charge in a single burst. Davy recognized his talents, and soon he became a lab assistant, helping with experiments like extracting sugar from beetroot. He analyzed the gases emitted by aging eggs, tested methods of drying various meats and fish as food for sailors, and isolated the organic chemical compound benzene. Then came bombshell news that turned his attention to another domain in science. Hans Christian Ørsted in Denmark had put a magnetic compass near his battery and was surprised to see that the compass needle moved. His discovery revealed that an electric current could generate a magnetic field. At the time, few scientists thought there was any connection between electricity and magnetism. The French physicist André-Marie Ampère then described the intricate link between electricity and magnetism through a detailed tapestry of mathematical formulas. Since Faraday couldn't lean on formulas and equations, he leaned into his intuition and powers of observation. He had to do his own experiments to understand a topic, which pushed him to design experiments that others hadn't dreamed of. One of his early experiments showed how electricity and magnetism could produce motion. He stuck a magnet at the bottom of a glass container, then filled the glass with a conductive liquid, mercury in his case, water with table salt in our case. He dangled a wire over the cup. When he passed an electric current through the wire rotated around the magnet. This rotational motion was due to the interaction between the magnetic field produced by the electric current in the wire and the magnetic field of the magnet. Faraday had built the world's first electric motor. 10 years had passed since his famous electric motor experiment. Though he had made other discoveries in between, something was nagging at him. If an electric current could produce a magnetic field, could the reverse be true? Could a magnetic field induce an electric current? His observations led him to a critical insight. It wasn't just the presence of a magnetic field that could induce an electric current, but the change in the magnetic field. Electricity only forms when the magnet is moved. When he moved a magnet inside a coil of wire, he induced an electric current, but when the magnet was stationary, no current was observed. This groundbreaking work demonstrated a two-way relationship. While electric currents can produce magnetic fields, the converse is also true. A changing magnetic field leads to the creation of electric currents, a principle known as electromagnetic induction. Fast forward to today, and the legacy of this principle can be seen every time a Tesla glides past you on the road.